To return more than one value from a function, we need to understand the concept of pointers. Pointers are unique to the C and C++ programming language. Even though other programming languages obscure the fact from the user that they are not using pointers, but in reality, at the back end, everything happens with pointers. So let's take a simple example to see what a pointer is. I have a simple declaration int I equals to 3. So when you make this declaration, there are three things that are going to happen. The first one is you're going to reserve space in memory. This is done by the compiler. The second thing is reserve space in memory, which is typically 4 bytes for the integer. The second thing that happens is we are going to store 3 in that memory location, which was reserved in the first step. And the third step is we are going to name the memory location as I. So we can take a memory map. Your memory map is going to look as follows. First, reserve a space in memory. So assuming that this is your memory block, 4 bytes in size. Whenever you reserve space in memory, you have a memory address, which is typically a huge number, 8 digit or a 9 digit number. So that's step one. Step two is store 3 in that memory. So store 3. So this corresponds to this corresponds to this. And we are going to name the memory as I, which corresponds to this. So these are the three things that happen when you declare a variable. The key takeaway here is that I's address in memory is a number. So the takeaway is I's address is a number. You can actually write a C program which will print the address of I. All you need to do is declare the variable int I equals to 3 and say printf percentile u comma ampersand I. Remember, ampersand stands for the address of operator. So you're basically printing the address of I, and when you print addresses, you give percentile u. U stands for unsigned, which means addresses can only have 0 to the highest value that an integer can hold, which is 4 trillion. It's typically negative 2.1 trillion to 2.1 trillion, but in unsigned, you go from 0 to 4 trillion. So your memory address can be anything between this value, and typically it's random. So when you run it on your compiler, it's going to show a different value, and when I run it on my compiler, it's going to show a different value. But it's typically a large number, something like this. Now, since your memory address is a number, we can in fact store that address in a variable. So how do you store it? So you might think int I equals to 3, int k, then I can say k equals to address of I. But this is not what is done. In fact, we do int I equals to 3. Then we have another declaration which says int star k. And then we write k equals to address of I. So this is your regular variable. This is your pointer variable. And this is basically saying k points to I, or k stores the address of I. Therefore, k is a pointer to I. So the formal definition of a pointer is a variable that stores the memory address of another variable. So that's the formal definition of a pointer. And this is the pointer declaration. So if you want to have a pointer declaration, you say int star, the name of the pointer. Here I just mentioned it as k. And then when you make this declaration, k points to null. Now, if you want to make k point to I, you need to store the address of I in k. Therefore, after doing this declaration, k points to I. So this is the concept of a pointer.